And welcome back to the Ubuntu Server Series. Today we're going to talk about DNS and DHCP. And I had a lot of white space on my slides, so I decided to draw an Android. And of course, what do androids dream of? Electric G's. Anyway, yes, you can tell that it's a Friday around these parts, so let's get right down to business, learn about DNS and DHCP as they work in Ubuntu. Now with Ubuntu, you have a couple options for DNS. If you're just looking for, something simple, there's things like TinyDNS. But when we're talking about serving DNS on a server, we're generally talking about the Bind version 9 server daemon. That's just the current version. That's what we're talking about for the most part when we talk about installing DNS on the server. And by default, Ubuntu ships Bind 9 set up as a caching name server. Now what that means is it doesn't actually host any domains or any names in and of itself, but what it does is it references a remote server. So you tell it what server you want it to point to, and it does just like the title suggests, it caches names so that DNS lookups on your local network are fast and efficient. It's not terribly difficult to set it up to actually serve domain names in your network or on the internet if you actually have them registered and you own them. We're going to set up a simple master DNS server for a made-up domain, and I'll show you how to do that. And of course, I'll briefly touch on how to set up a reverse lookup for that master domain, because a lot of things now, a lot of software really requires that reverse lookups work. And I made a note here, and I'll mention it probably 18 more times because that's how I go, is always increment the serial number inside a Bind 9 configuration file before you restart the server, because it determines on whether or not there's new information based on the serial number. It's kind of a silly thing, and it seems outdated, but incrementing the serial number is just something you have to do when you're messing with DNS. So let's go and set up our DNS server. After that, we'll set up a DHCP server. They're kind of tied together, and you'll see that in DHCP. But first of all, let's install Bind 9. So first things first, we're logged into the server here, and we're going to install Bind 9, and we're also going to install DNS utils, just because it includes utilities for testing and things like that. Okay, like most things with Ubuntu, that is all there is to installing Bind. The configurations are in etc. bind, and there are a couple files, well, quite a few actually. It's really nice. Most all of the files we're going to mess with are stored in etc. bind. A lot of different distributions kind of scatter these all over, and it's a real pain in the rear end. So I'm really happy that Ubuntu has just put them here. The configuration files are named.conf, name.conf local, and name.conf options. Why it's all separate? It's just one of those things that is a pain. But we need to celebrate that they're all in one folder. That's what we need to concentrate on. Now, the first thing, like I said, it comes configured out of the box to be a caching name server. And the way that we would configure our caching name server for our environment is to edit the name.conf.options file. And we go through here. Most of these are fine by default. What we need to change is we need to comment these out, or uncomment these, I guess. And forwarders mean, now it's caching domain name requests, but from what server? Well, we're actually going to use a generic. You can put the DNS of your ISP in here. That's a really smart thing to do, because then it's generally very fast lookups. This is Google's public DNS server. I know that this is going to be up. And so you put this in for your forwards or forwarders. You can put several in there if you want, but we only need the one. Then we can restart bind. And now let's see if it is working. Dig is a command to query specific DNS servers. Even though right now our local bind server isn't set up to be our DNS server, we can still query it by using the dig tool. So we'll say dig and then the @ symbol, what server we want to query, and what address we want to look up. Sure enough, it responded, which is awesome. So it responded, gave us the DNS information for Google. And if you want an example of what the caching does, see this query time here, 150 milliseconds to get the information? If we do this again, that should drop significantly because it should have that lookup cached. Let's see if I'm correct. Bam, query time 0 milliseconds. So the caching name server can really improve DNS lookup on your network. That alone is worth installing Bind on your server and have your computers point to it for DNS, right? Because all of these cached lookups are going to happen instantly, 0 milliseconds versus 150 milliseconds, which doesn't seem like, 150 milliseconds isn't much, but you combine that with every lookup you do and it starts to get kind of long. So anyway, that's how to set up a caching name server. It's a little more complex if we want to set it up as a master, but it's not that much more complicated. So we're in the etc bind folder where all of our files are stored, woot woot, and we are going to make this now, instead of just a caching name server, we're going to have it host a master, have it be a master for a domain in our network as well. It will still act as a caching domain, or as a caching name server. That won't go away. We're just going to add the role of master to it. In order to add that DNS zone that we're going to be the master primary server for, we need to, as root, edit name.conf.local, because we're going to be hosting this zone locally. The format for this isn't too difficult. We start with zone. What zone should we do? We don't really host Nugget Labs here. Let's make up a domain. We'll call it seansoffice.com. So this is going to be the zone that we host. If that really is a domain, I hope that it's nothing inappropriate, because I don't own it. And then open squiggly or open curly braces, type master. The syntax is something that you get used to, or you can find examples of configurations online, or you can just watch this. Obviously, I'm going to type it out myself. File. Now this means what file is the zone information stored in. Now for us, it's in etc bind. And we're going to do db.seansoffice.com. We'll close this section. Vim does this nice thing where it highlights if you have an opening and a closing curly brace, so you can see that we've actually properly closed out this section. And with a semicolon, we're going to save this file. Now remember I said that the name of the zone file was going to be db.seansoffice.com. Well, I don't actually have that file created. I'm going to cheat and copy the db.local file to db.seansoffice.com, and then I'm going to edit db.seansoffice.com, and we're going to change this to reflect our fictional domain that we're making up here. So this is set up. This is so you don't have to remember all of the syntax, right? I just copied one that I know is formatted correctly, and we're just going to go in and make changes. This top record is the start of authority, and this is the line where we add information about our domain, and we end it with that dot. That's kind of a funny thing about DNS servers, is it usually ends with the dot. And then this second line, root.localhost, this is actually an email address, and it's formatted with the dot, which is really bizarre, I know. So we're going to do seansoffice.com, again with that dot at the end of com. So this is an email address, but instead of the @ symbol, we just put a dot there. It's really bizarre, I know. And then most of this stuff we can actually leave the same, except we're going to add at the bottom here, we're going to add an A record so that we have something to look up, right? So let's go down here. Again, with the name server line here, we're defining the name server for the domain. This is not going to be localhost. That was for that local DB. So what is this going to be? We're going to say it's nameserver.seansoffice.com, and then we actually need to define what that name server's address is. This is IP version 6 stuff. We're actually going to get rid of this. So now we need to define that name server. So name server in A record, I believe this was .80, because it's the name server is going to be this computer, correct? So what we're saying here is the name server for this domain is ns.seansoffice.com, and here we're defining NS for this domain is 192.168.1.80. So here we're saying what the name server is, and in this line we're assigning that name server an IP address. So just so that it makes a little more sense, let's add another one. We'll say desk.seansoffice.com has an IP address of 192.168.1.11. And this is how it's set up. This is the format for setting up a zone file for this record. Now we could also do things like set up MX records for a mail exchanger. We could do CNAMEs. So here we've said that chair is a CNAME or an alias for desk.seanpowers.com. And do you remember my asterisk when I created the slide about DNS? I said to make sure to increment the serial number. Now here the serial number comes with a 2 in it. We could just increment this to 3, but there is a convention that most people use, and that convention is to do the entire year, then the month, then the day, and then a 2-digit number. So this is the first time we've edited it today. There, I just want things to line up well. There we go. So this 2013-062801, this doesn't have to be this way, but I'm setting it this way. It's kind of the standard that a lot of people use. And then if we go in there again today and edit it, we'll increment these last two to 02, 03, 04, 05, 06. But we know that we're never going to get repeating serial numbers because the date's always going to be increasing. Hopefully that makes sense. This is just a convention that most people use. You can just increment the number 1, 2, 3, 4, 5, but I like to do it this way. It's easier to see what's going on. Anyway, escape. We're going to save this file. Then we will restart the bind server. And it was waiting for the PID to die. That's kind of funny. Anyway, it killed the server. It started the server back up. And now let's see how it's working. If we dig at... So again, this is doing a DNS lookup on our local host, the @ symbol, and you put the IP address of the DNS server you want to query. And let's see if chair.seansoffice.com comes back with anything. Well, sure enough, it did. It said chair.seansoffice.com. Well, I know what that is. That's a CNAME for desk.office.com. And desk.seansoffice.com? Why, I know the IP address for that. It's 192.168.1.11. And then it goes on to tell us all about the domain name. The authority section, the name server for seansoffice.com is ns.seansoffice.com, and we defined that as well as 192.168.1.80, which is our server. So all of that information we entered, sure enough, it gave us all that information. Can we ping it? Why, of course we can. It's a DNS name now, so ping. Oh, now I'm very, very, very happy that that happened because it proves that I'm not paying attention to my own nugget. No, it proves that this is not actually a domain name, right? This is just something that we're hosting on our own. The only way that we got a response is when we use this specific name server. If we wanted this to be live, what we would do is come down here, and for DNS name servers, we would change this to our local host for the DNS server. So I've changed the DNS settings. All I need to do is restart networking, so it'll reload those settings. Hopefully we won't get disconnected from SSH. Networking stop, waiting, restarted. Now let's try to do that same thing that failed before. Now we're going to try to ping desk.seansoffice.com, and since our DNS server should now be 127.0.0.1, which apparently it's not. Well, that is frustrating, but the reason that we're not getting a response is that it already has a cached lookup to seansoffice.com on the internet, and it's just going to say, no, I already know that. I'm not even going to bother asking the DNS server. So a quick way that we can do this, quick because it's a pretty decent server, we're going to reboot the server. That will flush the cache. We'll be using our local DNS server, and doggone it, we're going to ping the fake domain name that we set up with our DNS server. All right, we're back up and running. Now, there, finally, we flushed the cache by rebooting the server, and so now the lookups to desk.seansoffice.com, they come back and we can ping it. And the reason is because we changed that network interface's DNS setting, And once we did that, now our default DNS server is the local host. So it's going to query our local host where we set up that master domain. Very frustrating when things like that happen. DNS works too well in that it caches fairly reliably so that it doesn't even try to look up when you do make a change. Anyway, it's back in this bind directory that we do those changes. One last thing before we move past bind, I want to talk about reverse lookups. Because remember, if you're familiar with DNS at all, you know that we just set up a forward lookup for the domain seansoffice.com. However, if we have to also have a reverse lookup working in order for a complete DNS setup to be fully functional. Things like Active Directory and OS X's Open Directory really freak out if reverse lookups fail. So on your network, if you're setting up a domain, a master domain, you really want to make sure that reverse lookups are set up, and this is how you do it. A reverse lookup functions very much the same as a regular master zone file, so we need to edit again the named.conf.local file, and we're going to add another zone. So go to the bottom of the file, we're going to add another zone, but this one's going to look different. Now if you're thinking, what on earth is that, Sean? Well, yeah, it is a little bit confusing looking. However, just know that it's going to be ARPA in-ADDR for the last two, and then if you read this backwards, 192.168.1, and then the last octet is what this zone file is going to serve out. So if you have multiple Class Cs in your network, you're going to have a reverse zone for each one. Hopefully that's not too confusing, but this is the layout for it. So hopefully this makes sense. Again, it's a master one. Notify, it's not going to send this to other DNS servers. The file is just a file on our system that we're going to create in a second, just like we did up here. And this is going to be a reverse lookup zone. Again, a little confusing, so just look at this format. If you want to you write this down, that might make sense. But let's we have to actually create that zone file now. So we'll save this. And just like last time, I'm lazy, so I'm going to copy the localhost reverse lookup file. So I'm going to copy db.127 to db.192. Remember, that's what I called it, was 192 in the file. In the named.conf.local file, I called it db.192. So we're going to do that. And now we have to modify it to reflect our actual network. Alright, just like before, hey look, it's just like our other master zone file. Well, yes, you are correct. We need to make changes so that it reflects our actual domain. We're doing reverse lookups for the domain that we just set, so ns.seansoffice.com. We'll leave the dot at the end. Remember, this is an email address. Sean instead of @dot at the end. Let's do our serial number. Now this is a different file, so we can make this one 01. If that's confusing to you and you just want to say every time I make a change to any DNS file I want to make it a different serial number, well that's fine. We can make this 2. Just, you know, it's going to be incremented every time somebody touches it, and that's fine. So we can make this one 2, or we could have left it at 1. It doesn't matter. It just has to be incremented above what this file was the last time the bind daemon started, and since it's never been there in existence before, it doesn't really matter what we make it this time, but I like to follow convention. So the name server for this domain is NS, and now we are going to define the IP address for this reverse lookup. Remember what it was before? It was 80, 192.168.1.80, so 80 is going to be what we put in our PTR record. This is going to be ns.seansoffice.com. So we've defined the reverse record for that. Now we also created another record, if you remember. I believe we made it 11. Again, the PTR pointer record, that's the definition for reverse lookups. And let's see, what was it? I believe it was desk.seansoffice.com. And now you may be thinking, and we also made that CNAME, you do not have to do a reverse record for a CNAME, only for the A records, because CNAMEs are aliases, and when lookups occur, they look to what is being aliased and make sure that that aliased domain name has a reverse lookup. So we do not have to add one for chair .sean'soffice.com. Just desk, just the one that we created the A record for. So we've done that. Now we need to restart bind again. Now I don't need to increment the db.sean'soffice.com serial number because I have not changed that zone at all. I have not made changes, so I don't need to increment that. All right? That's only when you make a change to the file do you need to increment the actual serial number. We'll restart bind 9, and now let's test our reverse lookup. And to do that, simply type host 192.168.1.11, and it will query our DNS server, and it says that's a pointer to desk.sean'soffice.com. Very cool. So we know that forward and backward are working because, again, we can dig desk.sean'soffice.com, and it's going to give us that IP address, and the reverse up here gave us that back. So forward and backward resolution is working. I know it's confusing, and the configuration files are kind of confusing as well. That's why I like to copy the DB files and just edit the appropriate bits. But that's all there is to setting up a bind server, and you can set up a fake domain in your network, and as long as you're pointing at your DNS server, it's going to be served properly. Okay, again, like we had those problems where we weren't pointing at the local DNS, and of course we couldn't do lookups. But if you're using your DNS server and that's what you're pointing at, you're going to get the responses that you expect. All right, let's move on really quickly to DHCP. It's a much simpler daemon to configure. Probably the most difficult part about setting up a DHCP server in Ubuntu is knowing what the dumb thing is called, because it's called ISC-DHCP-server. I know it's a little bit confusing. In older versions, it was DHCP3-server, but currently it's ISC-DHCP-server. Anyway, generally, when you do DHCP, like on your home router probably dishes out DHCP. Generally, you have a pool of IP addresses that you serve out, but it's also possible, like in a corporate network or in a work environment, or possibly in your house, to set up a static fixed address that can be assigned with DHCP. I personally do this for printers. I just find it very difficult to go into printers and assign a static IP in their menu system. I find it much easier to get their MAC address and then have DHCP assign them a fixed address when they boot up, because printers are something that you want to have a static IP. You don't want it to change. You want your computers to connect to it. So that's one use for assigning a fixed address with DHCP. But for most things, you just have a pool of IP addresses that gets automatically assigned. So let's install it and look at the configuration file very quickly. Okay, again, the hardest part of the job here, sudo apt-get install ISC DHCP server. Okay, that's it. It's set up. The first thing you need to do is go into etc default and edit the DHCP or the ISC-DHCP-server file. So if you edit this inside the etc default folder, it's going to have just this one configuration line. What interface is it going to distribute DHCP addresses from? Now, in our case, that would be bond 0. Remember, I still left those Ethernet bonds in place. So for right now, it's bond 0. If you had multiple interfaces on multiple networks, you may pick just one or multiple ones. Like it says, you can separate multiple interfaces with spaces, and then it would serve DHCP requests on both interfaces. For us, it would be bond 0. So I'm going to put that there, write that file, and then in etc DHCP, we find this file. Now, DHCPD is the file that we want to edit. This is a client configuration file. We are editing our server. Okay, so edit this file, and we get a nice default. Unlike the DNS configuration file, this actually gives us a pretty logical and easy to follow explanation file. So can leave a lot of this the same. Our domain name. What domain name means is, just like that search domain, when you assign a static IP address, this is going to be what domain? sean'soffice.com. Domain name servers. You can use domain names here, I highly recommend using a number. .80. Now, why can't we put 127.0.0.1 here? Because then all the clients would try to use their local host for DNS, and that's no good because only our server is running it, and our server has this 192.168.1.80 address. You can leave the lease time and the max lease time. That's how long the DHCP leases last. Logging can stay there and stay all the same. I'm going to scroll down here. These are the examples of how to define a subnet. We're just going to do the very basic one. Okay, so we'll uncomment this entire section. And what this is going to do, now this won't do us any good here. We want to make this our domain. 92.168.1.0 for our entire network, and our subnet mask is 255.255.255.0. If you have just a single class C address like this is going to be your net mask. This is outside of the scope of this nugget to talk about subnetting and subnet masks, but by default that's going to be just for a single 192.168.1 address. That's the setup there. And then the range, the start and end. So we're going to hand out 192.168.1. Let's start at 100 and go to 150. So now that's going to hand out a total of 50 addresses. And now routers. Routers, or what's another word for a router? Our gateway. This is so it's going to hand out an address from here in this range with this subnet mask. It's going to assign this gateway, and we globally told it what domain name servers to use. It's going to use these domain name settings, right? This search domain and this domain name server. Now we can specify that inside a subnet if we wanted to set a different domain name server for it to hand out, but that global one is fine. And this is all there is to set up a basic subnet declaration. Now if we hit escape, write this file, restart the server, and it says unknown instance because it didn't start up last time because it had no interface defined, but now it does. Now it has that bond 0 interface. So right now our server is serving DHCP across our network. We can do a quick search to see, and here it is. We can see that it's running. DHCP is running on port bond 0. So that's awesome. We know that it's running. That's all there is to set it up. Now DHCP is powerful. We're going to see in later nuggets that DHCP options can be used to set up bootp or PXE information for booting thin clients, but just to hand out addresses and network information, that's all there is to set up, just that simple subnet declaration. Okay, so that's how you set up your DHCP server. I'm actually going to shut mine down because I already have a DHCP server on my network, and I've just poisoned my network now with the DHCP service or server that is handing out addresses that it has no right to hand out because I'm on my local network and I already have a server running. So I'm going to shut that off. Just know that if you're setting this up on your home network and you turn on a DHCP server, you can really mess up all the computers that are connected. So your spouse out in the living room, when their laptop all of a sudden won't be able to get online, and you're going to be in trouble because you set up a rogue DHCP server on your own network. Okay, let's go back, make sure we have the things covered, and we'll call this nugget done. Alright, we learned how to install DHCP, how to set up that pool of addresses, and you know what? I didn't show how to do a static fixed address on our server. I think everything else is all set, so we'll finish off the nugget on the command line. So let's go back really quick, we'll finish up this nugget, and we'll move on. Back on our server here, we're going to edit that dhcpd.conf file. It really is a simple endeavor. Inside this subnet declaration, just hit enter a few times, make a space. All you do is before you close out with the last curly brace, you just add something like host printer 1, hardware Ethernet, and then the MAC address, which is like 12.ff. So it's a MAC address. You should be familiar with what MAC addresses look like. The next line, fixed dash address, 192.168.1.151. And then we'll close it off. So this lives inside this subnet declaration, and basically it assigns to the computer with this MAC address that I just made up this address instead of handing it one out of the range that it's set up here. So you assign a specific one, and when it boots up, it's going to query the DHCP server, and the DHCP server is always going to give it this address. That's all there is to configure a fixed address in DHCP on our server. I hope that this has been informative for you, and I would like to thank you for viewing.